What if everything we thought we knew about our place in the universe was about to change? Imagine a single object drifting through our solar system, defying the laws of physics, challenging the limits of science, and forcing humanity to confront the possibility that we are not alone. This isn't science fiction. This is the real story of 3I Atlas, the interstellar visitor that could rewrite the history of our species in a single night. If you're ready to follow this unfolding cosmic mystery and want to be the first to know what the telescopes reveal, make sure you subscribe and turn on notifications. The next update could be the most important astronomical discovery of our lifetime, and you won't want to miss it. Let us know in the comments. Do you think 3I Atlas will shatter our expectations, or will it confirm everything we thought we knew? Stay curious and stay tuned. The revelation arrived with an eerie calm, almost as if the universe itself was holding its breath. There were no sirens, no urgent news conferences, and not a single government alert. Instead, the world received a single, carefully crafted statement from the esteemed physicist Dr. Moaku, a message that read more like the final, reflective note of someone who had witnessed too much to remain silent. In his signature composed tone, the one he reserves for moments that upend the very foundation of scientific discourse, Dr. Moaku issued what he called his last and most serious warning about an object known as 3I, the third interstellar visitor ever detected by humanity, and by far the most enigmatic. For months, the global astronomical community had been locked in heated debate, with some experts dismissing the growing list of oddities as mere observational errors, while others insisted something extraordinary was unfolding. The object's shifting hue, its inexplicable acceleration that defied gravity, the immense plumes of gas erupting from its surface, the vast anti-coma stretching millions of kilometers, and a rate of mass loss that simply didn't fit any known model. All of these anomalies piled up, each more confounding than the last. Yet Dr. Moaku watched the data accumulate, noting every deviation from what a typical comet should do. Armed with the latest calculations, refined orbital predictions, and high-resolution images from both Chinese space probes and Earth's most advanced telescopes, he finally said what few dared to even consider. The numbers, he insisted, just didn't make sense. The energy required to produce the observed jets was far beyond what a single intact natural object of that size could generate. The jets, he argued, could not possibly be coming from the visible nucleus. And so Dr. Moaku declared that if 3I did not appear as a shattered cloud of debris by December 19, 2025, then the only explanation left was that it was not a natural comet at all. This pronouncement sent shockwaves through the scientific world, splitting it into two camps: those who feared Dr. Moaku was correct, and those who feared the implications if he was. Tonight, we delve into the meticulous calculations, the fierce debates, the professional risks, the 10 most troubling anomalies, and the stark warning from one of the most respected minds in astrophysics. This is the ongoing saga of a cosmic visitor that may soon force humanity to confront a reality we are not prepared to face. From the instant it was first detected on July 1, 3I Atlas refused to conform to the behavior of any comet astronomers had ever studied. It seemed to materialize from nowhere, entering our solar system on a trajectory that didn't match any known gravitational path. At first, it behaved as expected. A dust coma formed, jets of carbon dioxide erupted, and its shape appeared stable. But soon the object began to act in ways no one could explain. As 3I Atlas drew closer to the Sun, its behavior became increasingly erratic and baffling. Instead of following the predictable pattern of a comet gradually shedding ice and dust, its rate of mass loss soared to unprecedented levels. The anti-coma, a vast, ghostly cloud of material streaming away from the object, expanded to nearly 3 million kilometers, a distance that dwarfs the gap between Earth and the Moon. To put that in perspective, It was as if the object was leaving behind a trail so immense that it could wrap around our planet multiple times. The Chinese Tianwen-1 orbiter managed to capture detailed images, revealing colossal jets of material blasting from the surface. Yet, despite these violent outbursts, there was no evidence of the nucleus breaking apart. It remained stubbornly whole, defying expectations. Meanwhile, other observatories recorded a trio of phenomena that, on their own, would have been enough to raise eyebrows: a distinct shift in color, a measurable increase in velocity, and a significant acceleration that could not be explained by gravity alone. Each of these traits was unusual, but together they formed a pattern that was deeply unsettling. The only other time scientists had seen anything remotely similar was with Oumuamua, the first interstellar object ever observed, which itself remains a mystery due to its unexplained acceleration. By late October, the astronomical community was abuzz with speculation and unease. Something about 3I Atlas simply didn't add up. Even those who were usually cautious or skeptical found themselves unable to dismiss the mounting evidence. But it was Dr. Moaku's rigorous analysis that pushed the situation from merely strange to outright impossible according to the laws of physics. Dr. Moaku is not known for making wild claims. His reputation as a leading figure in theoretical physics and his decades of experience made his words carry significant weight. When he sat down to analyze the energy output required for the jets observed on 3I Atlas, he approached the problem with the objectivity expected of a scientist of his caliber. What he found was deeply troubling. The jets were so powerful and sustained that, for a natural object to produce them, it would need to expose at least 600 square kilometers of surface area to the sun, equivalent to a nucleus about 23 kilometers wide. However, the most detailed images from the Hubble Space Telescope showed that the object was no more than 6 kilometers in diameter. This represented a staggering 16-fold discrepancy, a gap so large that it shattered any hope of a conventional explanation. A natural comet cannot emit more energy than it receives from the sun, nor can it lose more mass than its surface area allows. It cannot withstand such intense outgassing without breaking apart, unless it had already fragmented into many pieces. Yet, the nucleus of 3I Atlas appeared intact. This was the point at which Dr. Moaku reached a conclusion that would ignite a firestorm in the scientific world. The only way the numbers made sense was if the object was not natural at all. Dr. Moaku did not mince words or attempt to soften the impact of his findings. He presented his conclusion with clarity and conviction. If 3I Atlas remained whole and unbroken by December 19, 2025, then the only logical explanation left was that it was not a natural comet. There was no room for ambiguity in his statement. He emphasized that a natural object simply could not violate the fundamental laws of thermodynamics. It could not produce jets so powerful that they required 16 times more surface area than what was visible. It could not maintain its structure under such violent forces without fragmenting. The only alternative, he argued, was that 3I Atlas was something engineered, perhaps a spacecraft or a technological artifact, created long before humanity ever looked up at the stars. Moaku explained that artificial thrusters, unlike natural outgassing, could generate much higher exhaust velocities, meaning they would need to expel far less material to achieve the same effect. In other words, a machine could produce the observed jets without tearing itself apart. This was the most controversial and career-defining aspect of his warning. If 3I Atlas was still in one piece on the critical date, then technology was the only explanation that fit the data. The reaction from the scientific community was immediate and intense. Moaku's statement did not just spark debate, it ignited a fierce and public conflict. Leading astrophysicists quickly voiced their opposition. Dr. Konyang Zhang from Lowell Observatory insisted that the comet appeared perfectly normal, with no signs of breaking up. Professor Brian Cox from the University of Manchester argued that there was nothing unusual about 3I Atlas, while Dr. David Jewett from UCLA suggested that the data had been misinterpreted. Dr. Chris Lint from Oxford went so far as to call the idea of an artificial origin an insult to planetary science. The criticism became personal, with some researchers accusing Moaku of misleading the public and damaging the reputation of science. Despite the backlash, Moaku stood his ground. He responded with a pointed statement, challenging his critics to expand their thinking. He argued that scientists who only study natural objects like comets and asteroids would inevitably misidentify something technological if it ever appeared in their data. This was not arrogance, but a warning, a reminder that every generation of scientists has faced moments when the universe forced them to reconsider their assumptions. Moaku had spent his career bridging the gap between theoretical speculation and observable reality, and now he was making his boldest prediction yet. While the debate raged, Moaku quietly published a list of 10 anomalies associated with 3I Atlas. Each one on its own was strange enough to warrant further investigation. Together, they painted a picture that was difficult to ignore: non-gravitational acceleration, unusual color changes, jets dominated by carbon dioxide, anti-solar jets that resembled thrusters, and the massive energy discrepancy that required far more surface area than was present. Each anomaly was a red flag, and collectively, they pointed toward an unnatural origin. The scientific world was left with a dilemma. No one could fully explain the data, but no one wanted to accept the alternative. All of this led to a single, pivotal date: December 19, 2025. The world's attention became fixed on this moment, the day when 3I Atlas would make its closest approach to Earth. On that day, the Hubble Space Telescope and the James Webb Space Telescope would be trained on the object, ready to capture the most detailed images ever taken. The stakes could not have been higher. If the object appeared as a fragmented cloud, the mystery would be solved in the most mundane way possible. A natural comet pushed past its limits, torn apart by the sun's relentless energy. But if the nucleus remained intact, the implications would be nothing short of revolutionary. This was the moment when theory and observation would collide, when the universe would either confirm or shatter the boundaries of established science. As the date approached, the scientific community found itself in a state of suspended anticipation. Researchers around the globe refined their models, ran simulations, and prepared for the data that would soon arrive. Some quietly hoped that Dr. Moaku's warning would be proven wrong, that the object would break apart and restore order to their understanding of the cosmos. Others, perhaps more adventurous, secretly wished for confirmation of something extraordinary. Most, however, simply wanted clear, undeniable answers. Meanwhile, 3I Atlas continued its silent journey through the solar system, glowing faintly as it accelerated and shed mass. The public debate grew louder, with media outlets and online forums buzzing with speculation. Was this truly a comet, or was it something else entirely? The question was no longer just a matter of scientific curiosity. It had become a test of humanity's readiness to confront the unknown. The heart of the issue was no longer whether Dr. Moaku's calculations were correct. The real question was whether society was prepared for what those calculations might mean. If 3I Atlas was natural, the world would breathe a collective sigh of relief and move on. But if it remained whole, if the jets continued to behave like controlled propulsion, if the mass loss continued to defy the available surface area, then the universe was sending a message that could not be ignored. It would mean that technology older than Earth itself existed, that intelligence predating humanity had left its mark in our skies, and that we were on the verge of a new era of cosmic understanding. This was no longer just a scientific puzzle. It had become an existential challenge. The implications reached far beyond astronomy, touching on philosophy, history, and even the future of our species. If 3I Atlas was a machine, a relic, or an artifact, then humanity would have to rethink its place in the universe. The story was no longer about a mysterious object in the sky. It was about the possibility that we were not alone, that we were being watched, or perhaps even tested by forces we could barely comprehend. As the world waited, the sense of anticipation grew. Telescopes were readied, models were updated, and scientists prepared for the moment when the truth would finally be revealed. In observatories across the globe, scientists sat in front of glowing screens, their eyes fixed on the slow, steady approach of 3I Atlas. Every pixel, every data point was scrutinized as the object inched closer to its moment of truth. For months, the debate had raged in academic journals, at conferences, and across social media. Papers were published and rebutted, anomalies were dismissed or defended, and reputations were put on the line. Yet beneath the surface of all this intellectual sparring, a quiet sense of unease persisted. Even the most conservative researchers, those who had spent their careers dismissing extraordinary claims, felt a subtle tremor of doubt. What if Dr. Moaku was right? What if the universe was about to reveal something that would force a complete rethinking of everything we thought we knew? The core of the dilemma was brutally simple. If 3I Atlas remained whole, the natural explanation would collapse. Comets, by their very nature, cannot break the laws of thermodynamics. They cannot lose more mass than their surface area allows, nor can they produce powerful, collimated jets without fragmenting under the stress. They cannot generate a 3 million kilometer anti-coma from a nucleus too small to support such a phenomenon. Nor can they mimic the acceleration profile of Oumuamua, the first interstellar object that had already left scientists scratching their heads. The only things known to survive such stresses and produce such effects are engineered objects, machines built with purpose, not accidents of nature. This was the fear at the heart of Dr. Moaku's final warning. It was not just a scientific concern, but a profound existential anxiety. What if humanity had been wrong about its place in the cosmos? What if, long before humans ever looked up at the stars, another intelligence had already crossed the void, leaving behind relics or artifacts that we were only now beginning to notice? If that were true, then 3I Atlas was not a comet, not a rock, not a random visitor. It was a messenger, a mechanism, a silent witness to a history far older than our own. The implications were staggering. If the object was artificial, it meant that technology older than Earth itself had survived the eons, drifting through space until it finally entered our solar system. It meant that the universe was not a silent, empty expanse, but a vast archive of civilizations that had come and gone, leaving behind traces for those who were willing to look. And perhaps, just perhaps, 3I Atlas was the first page of that ancient cosmic story that humanity had managed to turn. As the critical date approached, the world held its breath. Would the object shatter into fragments, confirming the natural explanation and allowing science to return to business as usual? Or would it remain whole, defying every expectation and confirming Dr. Moaku's warning? The answer would not just settle a scientific debate, it would redefine humanity's understanding of its own existence. The universe, it seemed, was about to deliver its verdict. As December 19th drew near, the world found itself teetering on the edge of revelation or relief. The final hours before 3I Atlas's closest approach were filled with a tension that was almost palpable, not just in observatories but in living rooms and classrooms around the globe. News outlets ran special segments, social media buzzed with theories, and people everywhere wondered what the telescopes would reveal. Would the object finally break apart, confirming the laws of physics and restoring the comfort of the familiar? Or would it remain whole, shining with that cold, impossible resilience that had made it so mysterious from the very beginning? If the images showed fragments trailing behind, the story would end with a sigh of relief. Science would chalk up the anomalies to the unpredictable nature of interstellar objects, and the world would move on, perhaps a little wiser but fundamentally unchanged. But if the nucleus stood unbroken, if the jets continued to erupt with inexplicable force, then Dr. Moaku's warning would become something far more significant, a turning point in our understanding of the cosmos. It would be the first undeniable clue that the universe is not a silent, empty wilderness, but a vast, ancient archive filled with the remnants of civilizations that came before us. 3I Atlas, in that case, would not just be a comet, it would be a relic, a machine, a silent messenger drifting through the stars long after its creators had vanished. Moaku's warning was never meant to frighten or sensationalize. He issued it because the data left him with no other choice. The numbers, cold and impartial, had forced him into a corner where only two possibilities remained. Either the universe was behaving in a way never before seen, or 3I Atlas was not what we thought it was. As the object drifted ever closer to Earth, humanity found itself suspended between dread and discovery, between the comfort of old certainties and the thrill and terror of the unknown. In the final moments, as the Hubble and James Webb telescopes prepared to capture their decisive images, scientists everywhere waited in silence. For months, they had argued, published papers, and defended their positions. But now, all that remained was the truth, whatever it might be. If 3I Atlas was still whole, the natural explanation would be dead. Comets do not break the laws of physics. They do not survive forces that should tear them apart. But engineered objects, designed with intent and purpose, can and do. This is the fear and the hope at the heart of Dr. Moaku's final warning, that we may not be alone, that the universe is far older and more complex than we ever imagined, and that we are only just beginning to read its ancient stories. If 3I Atlas is indeed a machine, then it is not just a visitor, it is a message, a challenge, and perhaps an invitation to look beyond our assumptions and truly see what is out there. As the world waits for the final answer, one thing is certain: the universe has never felt so close or so mysterious.